All right, so in this problem, we are given a figure. I'm gonna go ahead and draw that figure. So it tells us that our radius is 2 meters. It tells us this is point P, and at this point, there is a rest. So what that means is we need to emphasize, hey, my angular velocity at the initial point is 0 radians per second. Because we aren't moving, we are at rest at that point. And then it tells us that we move pi over 2 radians. We want to know the linear speed at this point, which is pi over 2. So we move an angle, we change an angle of pi over 2. So delta theta is pi over 2 radians. Now, the main question is, what is the linear speed at this point after we change an angle of pi over 2? So anytime you hear linear speed, think in terms of one-dimensional motion. Don't think in terms of rotational. So you're going to be given units such as meters per second, kilometers per second. We're not using rotational, so we're not going to be using units such as revolutions per minute, radians per second. That's not what we're looking for. We're looking for linear speed. So we're looking for a unit of meters per second. That should be our final answer. Okay, so we're looking for that speed at that point. So I'm going to go ahead and emphasize velocity final at that point is what we're looking for. But we have everything in terms of radians. So we'll switch from radians to meters in the last step, since we want linear speed. Okay, so now they also tell us acceleration is equal to 0.01 radians per second squared. All right, so we know that this formula is one of our kinematics, plus 2 acceleration times delta theta. That's a theta, sorry about that. This value, initial angular velocity, is 0. So I'm going to go ahead and cross that out. So we're left with final velocity squared is equal to 2 times acceleration times delta theta. I'm going to square root both sides to get rid of this square. Square root both sides. This isn't here anymore. So we have just this, just final angular velocity is equal to the square root of 2 times acceleration times delta theta. Now you plug all those values in. Square root of 2 times acceleration is 0.01 times delta theta times pi over 2 radians. Pi over 2. So plug that in. And you should get a value of 0.177 radians per second, because our units were radians per second squared and then just radians. Okay, and then the square root canceled out the squares of those units. Okay, so we have this as our final, but we need this in terms of linear speed. This is the answer. This could be our answer, but we need to put it in terms of linear speed. So I'm going to go ahead and erase this. Okay, so 0.77 radians. Consider that top part. 0.177, sorry about that. 0.177 radians is equal to x meters. We need this in meters. Just as 2 pi radians is equal to 4 pi meters. This is our circumference. We get this 4 pi from right here. Circumference is equal to 2 pi r, and our r is 2 meters. So our circumference is 2 pi times 2 meters. 2 times 2 times pi is 4 pi meters. This is our circumference, 4 pi meters. 2 pi radians is to 4 pi meters. They are equal. So these have to be equal as well. So do this, cross multiply. You should get a value of 0.35 meters. That's how much 0.177 radians is. And the question is asking for our velocity. So this is equal to 0.177 radians per second is equal to 0.35 meters per second. Because we saw that these right here are equal. Right here. So 0.35 meters per second. That's what our final linear speed is. And that's how you do that problem. So that's the answer.